Hello everyone, welcome to TechPrane YouTube channel. Today's video we look at the top 10 network troubleshooting commands. Ever faced network issues and felt lost? In this video, we'll work the top 10 commands to troubleshoot and solve networking problems like a pro, complete with common arguments you can use every day. Our primary goal is to provide hands-on knowledge of the top objectives, identify key network troubleshooting commands, learn common command arguments, execute commands in a command line interface on a Windows machine, and on Linux, you'll be using a terminal. Practical application of troubleshooting commands, troubleshooting using command arguments. Let's get started. Our first command is ping command. Ping tests basic connectivity. The purpose of a ping command is to check if the host is reachable and measures response time. Some common arguments that are used along with a ping command. We have on Windows, we have ping-t, which is the equivalent of ping-c on Linux. Continuous ping or specify the number of packets. Ping-a on Windows, and the same on Linux. Ping-a resolve the IP address to the host name. The next argument is ping-f, which is the equivalent of ping-s on line. Specify packet size. I'm now going to give you a practical example in the terminal. Example: ping-c 5, specifying the number of packets, google.com. We have a reply. We are receiving a reply. So send 5 ICMP echo requests to google.com. The target IP for google.com resolves to 192.178.5.4.110. Okay, so we can see the 5 TTL, time to leave. So this is the value in an IP packet that specifies the number of hops the packet can pass through before being discarded. And the time here is the round trip time. That measures the time it takes for a packet to travel to the destination and back. 5 packets transmitted, 5 received, 0% packet loss. Time, which is the total round trip time, 4094 milliseconds. Shorter time or shorter round trip time indicates a faster connection. A higher time suggests more latency, which could be due to distance, congestion, or network issues. Next command. Our next command is TRroot on Linux and tracert on Windows. This command traces packet path. It displays the packet path to reach the destination and identifies problematic hops. Some of the common arguments that are used along with the TRroot command or tracert command on Windows. On Windows, we have tracert, which is equivalent on the Linux. TRroot-n, show numerical IP addresses only. Skip DNS resolution. Linux machine TRroot-h, specify the maximum number of hops. Tracert-w, Linux TRroot-w, set a timeout for each response. TRroot-n, Google. So the traceroute, like I indicated, tracks the path packets take to reach destination, listing the routers or hops they pass through and measuring the response time. Here we can see the number of hops the packets are passing through to reach the destination. 15 hops before reaching the destination. An asterisk, it simply indicates a problem. So we have a problematic hops here, like hop number 6, hop number 10, hop number 11. Okay, so these are issues that can be due to a geographical distance, or probably a firewall, or ICMP filtering. So we can see the final destination here for our packets. It is reached successfully within 13 hops. Next command, ipconfig on Windows machine, which is the equivalent to ifconfig on Linux machine. This command shows network configuration. So the purpose is to view IP addresses, subnet, gateway, and DNS details. Some common arguments that are used together with this command. On Windows machine, we have ipconfig O, which is the equivalent of ifconfig on a Linux machine to display all network details. Is ifconfig with an interface shows details for a specific interface. Ifconfig down or up, disable or enable a network interface terminal. So here I'm just going to enter my command ifconfig. On this interface, Ethernet 0 and the loopback interface. So we can see that the IP address v4 or version 4 configured for this system or computer is 172.17.39.16. The subnet or its subnet, 255.255.240.0, and here is its broadcast, 172.17.47.255. The IP address version 6. Here is the MAC address. The loopback interface is also active and running. In this interface, Ethernet 0 is the primary Ethernet interface handling network configuration of this system. The loopback interface is used for internal communication within the host. Our next command in this video is nslookup, diagnose DNS issues. The nslookup resolves domain names to IP addresses. On Windows machine, we have nslookup. It's nslookup. Specify a DNS to query. nslookup-type mx. On Windows, same as Linux, nslookup-type mx queries specific DNS record types. On Windows, again, we have an argument used with nslookup, which is nslookup-debug. Same on the Linux machine, nslookup-debug show detailed query information. Lookup google.com. Okay, we have the information. So our command nslookup google.com 8.8.8.8 queries the Google public DNS server. We have the server information here. So the server used for the query was 8.8.8. This was the address on port number 53, which is the DNS port. Okay, non-authoritative answer. This is the response from a cache or recursive DNS server. On to our next command. In this video, our next command is netstat, active connection and ports. So the netstat command view active connections, listening ports, and network stats. Some common arguments that are used along with this command. On Windows, we have netstat-a, same as on Linux, netstat-a, to show all active connections and listening ports. Common argument is netstat-an on Windows, same as on Linux, netstat-an, display addresses in a numerical form, skip name resolution. On Windows, we have another one, which is netstat-b, to show executable involved in each connection. Netstat-a. Okay, here it looks like we have a lot of information. This simply means that we have an active internet connection, server and established. Okay, so we have TCP. For example, we have a TCP connection with this address 127.0.0.53 domain. So these are DNS resolver services running on loopback and a private IP. The state is listen means it means they are waiting for incoming connection. Then we have the UDP connection. So on the UDP connection, we also have the address 127.0.0.54 domain. DNS services using UDP protocol for faster queries. Okay, so we also have active Unix domain socket. This information down here is just simply showing that a socket for communication between Windows and WSL, Windows subsystems for Linux. I'm using a Windows subsystem for Linux. So this output indicates local network services, mostly DNS and the active with Windows subsystem Linux. Connection for Windows and the Linux integration. Okay, see the open ports. Open ports where it is listening means the port is open. Okay, we can see the state listen. Okay. And active connections. Okay, so netstat, let me simply say this is the output of the netstat. Command number 6 of this video is ARP table for IP MAC address mapping. So the ARP maps IP addresses to MAC addresses. What are some of the common arguments that are used along with this command? On Windows, we have ARP-A, and on Linux, ARP-A display ARP table. Again, another argument on Windows, we have ARP-D, same as on Linux, ARP-D, delete an entry from the ARP cache. Another argument, ARP-S on Windows, ARP-S on Linux, adds a static ARP entry, ARP-A. Looking at the output of our command, we can see the host name here. This is the host name associated with this IP address 172.17.32.1 at this is the MAC address associated with this device. So this is likely the primary Ethernet interface being used. Command number 7 of this video, route, view and modify routing table. So the route command display and modify routing table. Route print, which is the equivalent of route-n on Linux, displays the routing table. Next argument is route add on Windows, equivalent of route add on Linux, add a static route. Route delete on Windows, equivalent of route delete on Linux, remove a specific route. All right, here is the output of our command route-a. Okay, the information here is destination. So we have the destination, which is the target network address for the route, and the gateway IP address to reach the destination, the join mask, the subnet mask for the destination network, and the flags we have the U, which simply means the route is up and active. The G is for gateway route. Okay, metric, the cost of route, ref, number of references to the route, usually 0. Okay, use count of how many times the route has been used. First, the network interface used. In this case, the network interface that is being used is Ethernet 0. So the default route here is 0.0.0.0. All traffic not matching another route goes through gateway, 172.170.1 via this Ethernet or Ethernet interface. Then the network route is 172.17.32.0, which has direct access to 172.17.32.0/20 to this interface, Ethernet is 0. It does not require any gateway. Next command, dig advanced DNS query 2. So the dig command provides detailed DNS troubleshooting. The first argument we have is dig @symbol. With an @symbol, query a specific DNS server, dig domain name, then plus short, display a short summarized output. Dig -tmx, query specific record type. Dig at 8. Okay, one server found. The DNS server used is 8.8.8.8, which is a Google DNS server. Record type A for Google, google.com. Answer section, google.com. Record type A resolves to IP address 142.251.47.174. The DNS lookup took 195 milliseconds. The server used for the query was 8.8.8.8 port 53. The status here is no error, means the query was successful with no error. Okay, we have the date and time the query was made. Command number 9 is TCP dump, capture and analyze packets. So this command captures packets in real time for diagnostic. We have TCP dump -I, small letter I, with an interface, specify the network interface to monitor. So this is where you need to monitor a specific interface. TCP dump -N show IP addresses instead of resolving host names. TCP dump with a port number, it filters packets by a specific port. Sudo, I'm adding sudo to my command because it is the only way it is going to give me administrative privileges for the command to execute. Okay, we have now started receiving packet details. These packets show multicast DNS queries and responses, including IP addresses, lookups, and network device communication. I think it will still be going. So guys, I am going to cut it here because it is slow due to my internet connection. Okay, let's see, maybe it can film the CURL and the WGET. The command tests HTTP or HTTPS. This command tests access to the web servers. Capital I on Linux again, CURL -capital I. So that is this is not L, guys, it's capital. So this argument fetch HTTP headers only. That is when a CURL command is used. Then we have curl-o on Windows and same on Linux, curl-o, save output to a file. If we want to check the connectivity without downloading, we can use this command wget with the argument of wget -- or -- spider curl -I http://2.301 location content type k. So the http://2.301, the server is status, meaning the resource has been permanently redirected. Location, the new location for the resource is https://www.google.com. The content type, the content type is HTML. Content security policy specifies security policies for the page, such as restricting object sources and script sources to specific values. Date, the date and time the response was generated expires. The page is valid until up to this date indicated here. Cache control, the page is publicly cached for up to 30 days. So the server software used is GWS, which is the Google Web Server. All right, guys, so those were the top 10 commands. So practice these commands to build confidence in troubleshooting your networks. Master these tools and you will be solving networking issues like a pro. If you like this video, give it a thumbs up and subscribe to TechPrane YouTube channel. Thank you.